Hi, in today's lesson, we'll continue with our lesson on magnetomotive force and reluctance. We'll solve a simple problem that will help us understand it better. That said, let's get into class. Our work example says a mild steel ring has a radius of 50 mm. The radius r is equals to 50 mm. First, let's convert this to meters. That will be the same thing as 50 times 10 raised to power minus 3 in meters. And it has a cross-sectional area of 400 meters square. Now let's convert. That will be area now will be equals to 400 millimeter squared. Sorry, millimeter squared. Now let's convert it to meters. That will be the same thing as 400 times 10 raised to power minus 6 meter squared. Now, the current I in this system is the same thing as 0.5 amps in a coil, and the flux, it has a flux. The flux in this system is given as 0.1 milliwember. Now, that's the same thing as 0.1 times 10 raised to power minus 3 Wember. Now, if the relative permeability at this current, relative permeability U of R is given as 200. Now, we're asked to find the reluctance of the mild steel. Now, in our last lesson, we said that reluctance S is given as L, which is the length of the total material, over U naught UR times A, where L is the length, A is area, mu R is my relative permeability, and U naught is the absolute permeability, is the permeability of free space. U naught is the permeability of free space. Now let's note that U naught for free space is given as 4 times pi times 10 raised to power minus 7. Now, so that in this formula now, I can easily have my L, which is the length. The length will be the circumference of that ring, which will be the same thing as 2 by R now over U naught. We have U naught already, we have UR, and we also have E. Now let's impute these figures. It will be equals to 2 times pi times R. My R is 50 times 10 raised to power minus 3 over U naught. That's 4 times pi times 10 raised to power minus 7 times UR. That's UR times UR. That's my relative permeability, which will be given to be 200. This is my UR here, given to be 200 times 200 times the area A. The area A will be given to be 400 times 10 raised to power minus 6 times 400 times 10 raised to power minus 6. This line should extend this way, so that L here divides pi here. I have 50, I have 2. 2 here is 1, 2 in 4 is 2. I have 50 here, 50 here will be 1, 50 in 200 will be 4. Now I have 10 raised to power minus 3 and I have 10 raised to power minus 6. 10 raised to power minus 3 here should cancel. So 10 raised to power minus 3, 6 here, we left with 10 raised to power minus 3. Now, so that my S now should look like S should be equals to 1 over 2 times 10 raised to power minus 7 times 4 times 400 is 400 times 10 raised to power minus 3. So that this will be the same thing. If you use your calculator, kindly let's use our calculator. If I use my calculator, it should solve into 3.125 times 10 raised to power 6 per Henry. Now, the unit for reluctance is in Henry. Remember, the unit for resistance in electric field is ohms, but for reluctance in magnetic field is per Henry. So let's solve for the number of turns. Now, for my number of turns, we're asked to calculate, for the B part, we're asked to calculate the number of turns. But let's establish a relationship first before we begin to look at the number of turns. Now, the first thing I want us to remember is in our last lesson, which I'll place a link in the description, S is the same thing as, which is reluctance, is the same thing as magnetomotive force, Fm, over phi, which is the flux. Now, let's note also that my Fm is equals to Ni, that's the number of turns, times current. So that I can easily say that my S now is the same thing as Ni over phi. Now remember, we are looking for number of turns. So that this implies that my S will cross multiply S times phi will be the same thing as Ni. So that this implies that my N now will be the same thing as S times phi over I. So that this is equals to my S, that's the reluctance of the whole magnetic circuit, is the same thing as 3.125 times 10 raised to the power minus 6. This is the value here from what we solved. Now I can easily pick that. You can pick that, so that N now will be equals to 3.125 times 10 raised to the power 6. Now times flux. We're given the magnetic flux to be equals to 0.1 times 0.1 times 10 raised to the power minus 3. Now it will be divided by 0.5. Now, so that this is the same thing as 3.125 times 0.1 over 0.5 times 10 raised to the power minus 6, 10 raised to the power plus 6 times 10 raised to the power minus 3. That will be 10 raised to the power 3 from our lessons on indices. In case you missed our lesson on indices, we'll place a link to our lesson on indices to help you walk through it. And so that my N finally, if you use your calculator, N will come from 0.625 times 10 raised to the power 3, which is equals to 625 tons. With this, I hope you understand how to solve questions relating to magnetomotive force and reluctance in magnetic circuit. In our next lesson, we'll be looking at the magnetic circuit itself. To ensure you get that lesson, please do not hesitate to hit the subscribe button so that when we create that lesson and subsequent lessons, you'll be sure to receive our lessons. Thank you and see you in our next class.